Hello, my name is Alex Yu. I am a professor of data science and artificial intelligence in Hawaii. In this video, I will discuss SQL in the age of generative AI, the foundation behind retrieval augmented generation. Today, large language models are no longer limited to language or text alone. They have evolved into multimodal AI systems capable of understanding not only text, but also images, audio, and even video. Instead of writing a SQL query such as select GDP from World Bank where region equals to East Asia and year equals to 2025, we can now simply type a prompt like, give me the 2025 GDP of all East Asian nations. When AI feels this powerful and effortless, a natural question arises. Do we still need something as old school as SQL? In the rapidly shifting terrain of data science, where large language models, LLMs, often steal the spotlight, it is easy to assume that the old guard of technology, like SQL, is on its way to retirement. The reality, however, is quite the opposite. SQL remains the bedrock of the data science landscape, even as that landscape is reshaped by artificial intelligence. Far from being a relic, modern relational databases such as Microsoft SQL Server are evolving to support AI-centric workflows. They increasingly serve as the backbone for one of the most important patterns in contemporary AI systems, Retrieval Augmented Generation, RAG. To enter the field, understanding the synergy between structured data management and generative AI is no longer optional. It is becoming the standard for building reliable, production-grade intelligent systems. To see why this matters, it helps to first clarify what RAG actually does. A base LLM can be thought of as a brilliant student who has read an enormous library, but does not always remember facts precisely and may confidently hallucinate details when asked about specific or private information. RAG changes this dynamic by giving the model access to an external, trusted knowledge source at query time. Before generating an answer, the system retrieves relevant passages from databases, documents, or knowledge bases and injects that context into the prompt. In effect, the model is taking an open book exam. This grounding mechanism dramatically improves factual accuracy and makes AI systems suitable for enterprise scenarios such as financial reporting, internal policy support, or clinical documentation, domains where imagination is a liability rather than a feature. This is where SQL reasserts its relevance. If the AI model is the brain of an intelligent system, the data pipeline functions as its circulatory system. And SQL acts as the valve that ensures the right information flows to the right place at the right time. In a RAG workflow, the pipeline must both prepare data, cleaning, structuring, and governing it, and retrieve data efficiently at inference time. Modern SQL platforms increasingly support this role by enabling hybrid querying patterns that combine traditional relational filters, for example, dates, identifiers, or access permissions, with semantic retrieval based on embeddings. While SQL Server and similar systems are still evolving in their native support for vector search, they are clearly moving toward tighter integration with AI workloads, often as part of broader architectures that pair relational databases with specialized search or vector services. While SQL and vector databases optimize for different epistemic tasks, SQL anchors semantic retrieval within an auditable, secure, and well-governed data foundation. Looking ahead, a natural question arises. As multimodal AI systems become better at interpreting images, audio, and video, will the importance of SQL diminish? The answer is almost certainly no. While AI models will continue to improve at extracting meaning from unstructured data, organizations will always need a reliable source of truth. Business operations, regulatory compliance, healthcare records, and financial systems demand data that are consistent, traceable, and ACID compliant. ACID compliant describes a database system that guarantees reliable transaction processing by ensuring atomicity, transactions fully succeed or fully fail. Consistency, each transaction preserves valid database rules. Isolation, concurrent transactions do not interfere with one another. And durability, committed changes persist even after failures. Together, these properties ensure that database operations remain correct, predictable, and auditable under concurrent and fault-prone conditions. You might use a multimodal model to analyze an X-ray or summarize a customer call, but you will still rely on a SQL database to manage patient histories, billing records, contracts, and permissions with absolute precision. In this sense, SQL is not merely a query language. It represents a philosophy of disciplined, structured thinking that keeps complex systems accountable. As AI agents become more autonomous, the role of data professionals will continue to shift. Rather than writing every query by hand, practitioners will increasingly act as AI orchestrators, designing schemas, constraints, views, and retrieval frameworks that guide intelligent systems towards safe and trustworthy behavior. SQL, far from fading away, becomes one of the primary tools for imposing order, governance, and clarity in an otherwise probabilistic AI world. What do you think? I'd love to hear your thoughts. Drop a comment, share this with others who are thinking about the future of data and AI, and give it a like if you found it useful. Thank you for watching. Goodbye.